All right, good morning, everyone. Continuing on with quadratics in quarantine. We are now done our first of 3 quadratic units. In this unit here, we're going to be doing a lot of factoring. So today is sort of a review lesson that's going to help us lead up to factoring. So a lot of what we're going to do today is grade 9 or the grade 10 review, but we'll go over it just to make sure we're all on the same page. So then moving forward, hopefully we're good. So we're going to be looking at polynomials today and multiplying polynomials and a little bit of adding and subtracting them as well. So first of all, a polynomial is made up of a bunch of terms. So if we have something like 7x squared plus 3x plus 2, that's a polynomial. Poly meaning many, and we have many terms here. So a term is either a single number. So this is a term right here. In this case, we actually have 3 terms. And remember, the sign out front goes with the term. So this is a 3-termed polynomial. And so a term can either be a single number, or it could be a number and a variable multiplied together. So in this case, this is 3 times x. It's a number and a variable multiplied together. And it could also be a number and a variable multiplied together, and that variable is to an exponent, of course. So in this case, our variable would be x. It's the unknown. So this is a variable, this is a variable. When we're talking coefficient, we have 2 coefficients here. We have 7 and we have 3. So 7 is the coefficient in this term. 3 is the coefficient in this term. We do have a constant in this polynomial. That constant is 2 or plus 2, and that's what we're talking about right here. So this term is a constant as well. Now, polynomial means many terms, so we have many terms. We have more specific names. If it only has 2 terms, we would call it a binomial. If it has 3 terms, that's a trinomial. This here is a degree. And we can only add and subtract like terms. So a like term is a term. So like term is a term that has the same variable to the same degree. So 3x squared and 4x squared and minus 7x squared, these are all like terms because they have the same variable to the same degree. 3x squared is not like 3x. This is an x squared, this is an x. They are unlike each other. All right, so something that you learned in grade 9, or you reviewed and hopefully perfected, collecting like terms. So if we have a question like 2x squared plus 3x minus 5 plus 6x minus 7x squared minus 2. First thing I want to do is I want to find my like terms. So we have a plus 2x squared here and a minus 7x squared. A 3x, or a positive 3x, and a positive 6x, and a negative 5, and a negative 2. And if you recall, what we want to do is we want to collect like terms. So we want to put our like terms beside each other. So we got 6 parts to this polynomial, and we could rearrange those parts in any way we want to. So I'm going to take this 2x squared and my minus 7x squared, put them beside each other. I'm going to put my 3x and my 6x beside each other. They are like terms. And my minus 5 and my minus 2. Good habit to get into, putting these in an order with the variable to the biggest exponent first. So you notice I put my x squareds, then my x's, then just my numbers. If I had x to the power of 3, I would have led with those as well. And now what we can do is we can add or subtract like terms. So I can take 2x squareds, subtract 7x squareds, and that would leave me with minus 5x squareds. 3x's and 6x's altogether, that's 9x's. And minus 5 minus 2 more is minus 7. So fairly easy and straightforward, I hope. All right, exponent rules. So I just want to review those a little bit. If we have a question like 8xy squared times minus 7x squared y cubed. So remember an exponent or our exponent rules. Let's just get into this question and we'll deal with it there. So in this case, what I'm going to do is I'm going to multiply. And when we are multiplying, actually I will write this out here. When we are multiplying two exponents with the same base, so we might have an x3 times x2, we keep the base and we add the exponents. So 3 plus 2 is 5. Likewise, if we are dividing, we go the opposite way. So we keep the base and we subtract. 3 minus 2 is 1. These rules only work with the same base. So if we have an x squared times a y squared, we can't do anything with that. We can only utilize these rules if we have the same base and we keep the same base in the answer. Now in this case, what we do here is we are multiplying everything in this bracket by everything in this bracket. And this becomes a three-part process. So I've identified my coefficients, 8 and minus 7, so I'm going to multiply those first. 8 times negative 7 is negative 56. Then I'm going to multiply my like exponents. So that's 8 to the power of 1, of course. So x to the power of 1 times x to the power of 2. We keep the base and we add the exponents. 1 plus 2 is 3. And y2 times y3, we keep the base and we add the exponents. 2 plus 3 is 5. Hopefully that's bringing back some bad memories from grade 9. Now, I just want to go back to our exponent rules here as well. So these exponent rules are working when we are multiplying or dividing by the same base. Of course, if we are adding or subtracting, it doesn't work that way. So if we have 2x squareds plus an x squared, this is not multiplying. We are not keeping bases. We are not adding exponents. Really what this is saying here is we have, if I could draw this out for you, we have 2x squareds. And if we add to it another x squared, what do we have? Well, we have 1, 2, we have 3 x squareds now. So when you're adding or subtracting, you are literally just adding the coefficients. All right, let's do a couple more examples here. We have 15a7b4 divided by minus 3a3b. Once again, we are going to look at our coefficients. 15 divided by negative 3 is negative 5. a7 divided by a3, keep the base, subtract the exponent. 7 minus 3 is 4. And b4 divided by b1, keep the base, subtract the exponents. 4 minus 1 is 3. All right, third example here that you've seen before is something like this. This is an exponent to an exponent. And sort of our rule here is if we have x squared, so we have an x squared here to the power of 3. What this is really telling us is we have x squared times x squared times x squared, right? If we have 7 to the power of 3, that would be 7 times 7 times 7. The base times itself 3 times. So here is our base, and we're timesing it by itself 3 times. So 1, 2, 3. Now we can use this rule. Because we are multiplying all the same base, we keep the base and we add the exponents, 2, 4, 6. So that's it expanded out. I don't expect you to do that. I'm just reviewing with you the math behind the math. In this case, our shortcut is when you have an exponent to an exponent, you can multiply them. So you keep the base, which is x. 2 times 3 is 6. And you'll notice you arrive at the same answer. So in this case, we have 3 things inside the bracket. And the first is my coefficient, and it gets squared. So 2 times 2 times 2 is equal to 8. Number one mistake you will make, my students always make, is they forget to do that they forget to, in this case, cube the coefficient. So don't forget that. And then c to the power 2 gets cubed. We keep the base. And because it's a power to a power, we multiply. 2 times 3 is 6. And then once again here, we have a power to a power. Keep the base. 3 times 3 is 9. So we have simplified that as well. So there's some a little bit of review of exponent rules. All right, let's do some adding and subtracting of polynomials. So here what we have are 2 polynomials that we're going to add together. When I teach this in grade 9, I often talk about bowls of fruit. So I say we have a bowl of fruit here, and this has blueberries in it. And we have another bowl of fruit with blueberries in it. And in the first bowl here, we have apples, green apples, and we have green apples here. And these are blueberries because they're like terms. These are apples because they're like terms. And basically, this is telling us to add these 2 bowls of fruit together. So when I do that, perhaps you'd like seeing the terms like this. Basically, I'm going to take these 4 groups of fruit, or these 4 terms, and I'm going to put them all together. That's what this plus is telling me to do. So when I do that, I'm going to put my 5 blueberries and my 2 blueberries beside each other, and my 7 green apples and my minus 11 green apples beside each other. And then I can simplify. I can say that I have 7 blueberries, and here 7 apples minus 11 apples is minus 4 apples. I can't go any further, of course. These are unlike fruit. These are unlike terms. And so we are done with that. All right, so a bowl of fruit with 3 different fruits in it. In this case, we have another bowl, and it is asking us to take stuff out. So some of this seems easy. We have 5 apples, and it's asking us to take out 2 apples. That's easy enough. We have 6 blueberries, and it's asking us to take out 5. Well, that's easy enough too. Here's where it gets tricky. We have 8 strawberries, and it's asking us to take out -9 strawberries. We don't have -9 in here to take out. So without getting too deep into the math behind this, hopefully your math teacher went over that with you in grade 9. What the solution is mathematically is we add the opposite. So in this case, what I'm going to do is I'm going to come back, and instead of subtracting this bowl of fruit, I'm going to add in the opposite. So I'm going to add in the opposite of all this. The opposite of 2x squared is minus 2x squared. The opposite of plus 5x's is minus 5x's. And the opposite of minus 9 is plus 9. And so now we can do this question. It's exactly the same as this one. I am going to put together, it's now telling me to put together my green apples. So my 5x squareds and my minus 2x squareds. When you are adding the opposite, go back and change these. I see students not physically change them, and when they start to collect like terms like I'm doing now, the new sign often gets forgotten. Maybe you'll remember for one, but not for the other. As soon as you bring the old sign over, then you're gonna get the question wrong. So physically change it, you don't make simple mistakes. All right, my 6 blueberries and my minus 5 blueberries, my 8 strawberries, and my now 9 strawberries. And now I can add together like fruits or like terms. 5x squareds minus 2x squareds are 3x squareds. 6x's minus 5x's is 1x. And 8 and 9 is 17. Now that's a plus 17 and that's a plus 1. Don't forget those, because sometimes I see students write this out. They have a 3x squared and an x and a 17, and they literally write out the solution like this, and this is wrong. It's this plus this plus this. So make sure you've included everything. So that is just a review of adding and subtracting polynomials. I just want to do a review of multiplying and dividing polynomials. And we call this distributive property. And the way distributive property works is this is minus 3 times a polynomial, in this case a binomial, 2 terms. And so every term inside the brackets has to get multiplied by negative 3. So it's negative 3 times this, and it's negative 3 times this. So negative 3 times x is minus 3x's. Negative 3 times negative 6 is positive 18. Likewise here, trinomial, 3 terms. Every one of those terms gets multiplied by the 5x. So 5, and we kind of talked about this, how we do this back in this sheet here, especially back in this question where we did the 8 times negative 7 are coefficients. So same thing here. This is actually a 1x squared. So it's 5 times 1, which is 5. x1 times x2. Keep the base, add the exponent. 5 times negative 4 is negative 20. x1 times x1, keep the base, add the exponent. 5x times 1 is just 5x. All right, we have a question here. It has a little voice crack there. Multiplication here, distributive property, minus 7h times everything inside the bracket. But we also have a subtract here. So we have to follow BEDMAS here. I have to make sure that we are doing our multiplications first. Whenever you have something up against a bracket, it's implied multiplication. And we deal with that afterwards. Now in this case, we're gonna actually, that subtraction will disappear as we go along, but just a reminder that we don't try to deal with that at the onset. So here we have minus 7h times everything in the bracket. So minus 7h times 2h is minus 14h squared. Minus 7 times 2 is minus 14. H times h, h squared. minus 7h times 5. So minus 7 times 5 is minus 35. And h times nothing just stays as an h. Now here's where we're going to lose that subtract, because we will do minus 4h times 5h. Minus 4 times 5 is minus 20. H times h is h squared. Minus 4 times minus 3 is positive 12. H times nothing, we keep an h. Now we have two like terms. I'm not going to collect like terms here. I think a lot of you are probably at the stage in your mathematical career where you can just sort of do this without rearranging them and putting them beside each other. That's fine as far as I'm concerned. So minus 14h squareds minus 20 more h squareds leaves me with minus 34 of those h squareds. And minus 35 h's plus 12 h's is minus 23 h's. Minus 35 plus 12 is minus 23. And one more quick question here. So 2x plus 7x. All right, so bad math once again applies. We have to do multiplication before adding or subtracting. We do have a 7x, or sorry, a 2 plus 7x. Don't do that first. We do the multiplication first. The 7x times everything that's inside the brackets. So of course we are going to just carry down everything from the line above. So 2x gets carried down. And we will carry this all down simplified. So 7x's times an x. 7 times 1 is 7. X times x is x squared. 7 times negative 3 is negative 21. X times nothing there is x. And now we are going to collect like terms and simplify. I'm going to put my plus 7x squared out front. It's got the bigger exponent. And then I'm going to take my 2x's, subtract 21x's, which leaves me with negative 19x's. And of course, I can't do anything with those. They're unlike terms. I cannot put two different fruit types together. All right. In all these cases that I just did with you, we were multiplying a monomial by something. So we had blah, blah, plus blah, blah, plus blah, blah. So this was a monomial, a one-termed thing. And we're multiplying that out. What we're going to do right now is we're going to multiply binomial by a binomial. So that's where we get a question like x plus 2 times 3x plus 5. And hopefully your grade 9 teachers showed you different couple ways of doing it. I always give the example, I teach my students in grade 9 how to multiply teens by teens. So a question like 17 by 13 I can do in my head. That's 221. And I'm no math genius, that's for sure. Not a beautiful mind here. But what I do is I envision that like an area question. So we have 13 by 17. And what I do is I break this up in my head. I break this 17 up into a 10 and a 7. And I break the 13 up into a 10 and a 3. The reason I do that is I'm really good at 10 times tables. And so I envision this as 4 different areas. So I figure out the 4 different areas and then I add them together. So this area here is a 10 by 10 area, which is 100. This area here is a 10 by 7, so that's 70. This area here is a 10 by 3, which is 30. And this area is a 3 by 7, which is 21. Add those all together and you get 221. So you can do those very quickly in your head. The teens are easy because if you're breaking it up into a 10 and a 7 and a 10 and 3, so right away, because I'm multiplying two teams, I know that's 100, 70, 30 more, so I'm at 200 now. And then the only real math I have to think about is the 7 times 3, which is 21, so 221. 15 times 12, same thing. I have 100, 10 times 10 is 100, 5 times 10 is 50, so I'm at 150, 170, and then 5 times 2 is 10, so I add 10 more on. So graphically, that looks like this. 10 and 2, which is 12, 10 and 5, which is 15, 100, 50, 20. So I'm at 170, 2 and 5 is 10, which is 180. So if you practice that a little bit, you can actually become very proficient at it. And as you see, I just rhyme off the first three numbers. 100, 150, 20 more is 170, and then I just deal with that. We can use that same concept for doing these, because I have a binomial times a binomial here. So one way that we can do it is the same as this. I can do x plus 2. But what I'm going to do is, the same way I took my 17 and I broke it up into a 10 and a 7, I'm going to break it up by term. So there's my x times 2, and that's going to be 3x times 3x plus 5. I'm going to break it up by term as well. And so now what I'm going to do is multiply out these four things, and then, like I did here, add them together. So x times 3x is 3x squared. X times 5 is plus 5x. Get in the habit of making sure you have your plus 5, the plus with it. 2 times 3x is 6 plus 6x's. And 2 times 5 is plus 10. And now I'm going to add all these together. So 3x squared plus 5x plus 6x plus 10. I added them together in order of descending exponents. I can obviously stick those two together because they are like terms. So 3x squared plus 11x's plus 10. There's my answer. Now, you were probably also taught the FOIL method. I don't care which method you use the one that's easiest for you, the one that will lead to less mistakes, the one that you understand. But the FOIL method is this. FOIL is an acronym that stands for firsts, which means that we're going to multiply together the first term in each of these binomials. And then we have the outsides. So this is an outside, it's on the outside, and 5 is on the outside of this whole question. So we're going to multiply those two together. Then we're going to do the insides. So this term and this term are on the inside of the equation. And the lasts. So this term and this term are the last in each equation, or in each binomial. So if we do that, the first x times 3x is 3x squared. Our outsides, x times 5 is plus 5x. Our insides, 2 times 3x is plus 6x. And our lasts, 2 times 5 is 10. We can simplify those. So 3x, 5x's, and 6x's are 11x's plus 10. We get the same answer. So whichever way you want to do it, you do it. So here, x minus 1, x plus 3. I'll do these two different ways. So this one I will do this way. So I have x and minus 1, x and 3. x times x is x squared. X times 3 is plus 3x. Minus 1 times x is minus x. Minus 1 times 3 is minus 3. Putting them all together, I can simplify those. I can do those terms together. 3x's minus an x are 2x's, and we are done. In fact, sometimes I use the FOIL method, and I just do this. So I don't draw the whole thing out. And even if you feel comfortable, you can skip this step, put those two together in your head or on your calculator, and then add that one in. And for those of you who are FOIL purists, apologize, John Carlo, this is a long lesson, but it's a bit of a review lesson that's going to help set us up. So our firsts, 3x times 4x are 12x squareds. Our outsides, 3x times 5 is plus 15x. Our insides, negative 2 times 4x is minus 8x. And minus 2 times 5 is minus 10. Stick those together in simplifying. 15 minus 8 is 7x's minus 10. And one more question here, and then we will try to move on to a couple word problems, and we will be done. A couple more questions. So once again here, 2x times x is 2x squared. 2x times negative 1 is minus 2x. Minus 3 times x is minus 3x's. And negative 3 times negative 1 is positive 3. Simplifying our like terms, we have negative 2 minus 3. Negative 2 minus 3 x's is minus 5 x's, and our plus 3. And one further question here. Just going over a selection of question types that you may see, so you have some experience with them. Here we have this times this times this. You can do it in whatever order you want. You can multiply this by this, and then take that and multiply it. In this case, I'm just going to get my FOIL out of the way. So here we have minus 2 times x, 2x's times x is 2x squared. Here, 2x times 4y is 2 times 4 is 8. X times y is xy's. Ooh. 3y times an x. 3 times 1 is 3. Y times x is, I'm just going to, instead of saying yx, I'm going to make them look the same. Same thing. And our last 3y times 4y is plus 12y's. And now we have a distributive property question. 2 times everything inside the brackets. So we get minus 4x squareds. Actually, I should have put these together first before I started doing my distributive property to make it a trinomial inside. So 8xy's plus 3xy's is plus 11xy's. I'm not going to redo that line out, but here we go now. So we did 2 times this, now 2 times that. Negative 2 times 11xy's is minus 22xy's, and minus 2 times this guy is minus 24y squared. And that should have been a squared to begin with. I forgot that 3 times 4 is 12. Y times y is y squared. So found my mistake. Easy to make. I make a lot of them. All right. I know your questions, there's another one that comes after this. Actually, in this question here, we can do our distributive property, and then we'll take that answer and FOIL it out. I will quickly write the solution down with you. I realize this is dragging on. So 3 times this, we get that. And I'm gonna do my distributive property here, and we get that. Foiling this out, 6x squared minus 6x plus 6x minus 6. And then I'm just gonna carry this down. Collect like terms, so 6x's minus 6x's plus 6x's gives me, or sorry, those are all x squareds. Sorry, that should not be there. All right, so we have a 6x squared. We have a minus 6x plus a 6x plus a 2x, so plus 2x's. And we have a minus 6 and a minus 6, which is a minus 12. All right, one more question here, then we'll do 2 word problems. All right, so the distributive property, or Bedmast says we're gonna do this and this first, and we'll deal with the subtraction second. So foiling this out, we get this. Foiling this out, we get this. This is a polynomial minus a polynomial. We know what we do here. We add the opposite when we are subtracting them. So this becomes a minus, this becomes a minus, this becomes a plus, and this becomes a plus. We can put it all together, and we end up with 4x plus 14. So I did this, x squared minus x squared, no x squareds left, 5x's plus 2x's minus 4x's plus an x, these would be with 4 x's, and 10 and 4 is 14. All right, couple word questions, and then that is that. So here we have a shape. This side is x plus 5 long, this side is 4. This is an x, and this is a 3. And we have to find the area. So this is a compound shape. I'm gonna break it up into 2 rectangles, and I'm gonna add them together. So rectangle 1, my formula for a rectangle, or maybe it's a square, is length times width. Now my length here is 4, so it's gonna be 4, and my width is right here. That's gonna be x and 3 added together. Right? That plus that is this. So it's gonna be 4 times x plus 3. Now the key here is if you just write down 4 times x plus 3, you're going to do this wrong. So you have to make it 4 times x plus 3. It's 4 times all of this. So make sure you're using your brackets. If not, if you don't have the brackets, you're gonna do 4 times x, which is 4x, and then you're just gonna try to add 3 onto it, and you're gonna get the wrong answer. So it's this times all of this. And now you can see we've got a distributive property question. In A2 here, we have a length of 3, and we have a width of, this distance here is gonna be x plus 5 minus 4. If we do that, that will give us this. So whatever this is minus this will leave us with that. And then to simplify this, we have x. So that's an x plus 5, and that leaves us with a minus 1. So there's our two areas. And so the total area here would be area of one plus the area of the other. So we have our first plus the area of our second one. And we solve. We do our distributive property here, 4x is plus 12. We do our distributive property over here, plus 3x is minus 3. We collect like terms and simplify. I feel like I made a mistake here. That's a plus 1. 5 minus 4 is 1. I know Catherine's been shaking her head for 3 minutes now saying, Mr. Mitchell, what the heck are you doing? So that's a plus 1. That's a plus 1. 12. And 3 is plus 15. There's our simplified area for that. Sorry for that, ladies and gentlemen. And we're going to do one more question, and then that is it. I realize we're closing in on the 45-minute mark. So we have, in this case, we have a square patio. And our square patio has a side length of x. So we know basically, because it's a square, all the sides are the same. It says that if we increase one dimension by 2 meters and increase the other dimension by 3 meters, hopefully this question is asking us to, well, first of all, let's follow the notes that you have. So for this, it says A, write an algebraic expression for the area of the original patio. So original patio is length times width, of course, subbing in what we have, x times x, and that's x squared. I'm sure a lot of you went straight to that, just showing you the progression. B says write an algebraic expression for the area of the new patio. So it says for our new patio that one side is increased by 2. The other side is increased by 3. And so the area is length times width. The length here is x plus 3. The width is x plus 2. Remember, use your bracket so it's the whole length times the whole width. We can FOIL this out, and we get x squared plus 2x's plus 3x's plus 6. And there we go. We have the simplified area of the extended patio. And C says to simplify. That's sort of what we did right here. We simplified. And D says find an expression that represents the increase in area. Well, the increase from here to here is basically if we take this one and subtract that one, it leaves us with the increase. So let's take, so basically the second area here. If we do that and we subtract the first area, that'll give us the increase. So let's do that. We have x squared plus 5x's plus 6. And we are going to subtract the original one, which was that. Polynomial, subtract a polynomial. We add in the opposite. And now we can simplify x squared minus x squared, 0x squares, they're gone. And we are then left with 5x plus 6. So that is the increase. Long lesson. I apologize for the length of that, but a lot of different things that we had to quickly review. Hopefully, because this is review, your homework goes fairly quickly. And then we will get back into more of a quadratic application next lesson. All right, have a good day, everyone.